Hi Algebra 2 students. This week we are going to get started with our unit on quadratic functions and equations. And we'll spend most of quarter 2 actually working with quadratics. So our first topic is to learn how to write and graph the rule for the transformations. So we'll be applying those exact same transformation rules that you learned when we were working with absolute value functions and just looking at general parent functions early on in the year. Now before we actually start transforming quadratic functions, let's look at the parent function itself. So a quadratic is a function of this form, okay, that's our vertex form, and the parent function in particular is x squared. The U-shaped curve that a quadratic function makes is called a parabola. So let's just do a quick comparison between linear functions that we're very familiar with and quadratic functions. So first, if we look at the function itself, we'll see a quadratic function has the x squared, where a linear function it just has x to the first power. Now if we move on to our table, they have 2 points in common. The first one is 0, 0, and the second is 1, 1. And maybe you recall from sections 1.8 and 1.9, almost every parent function has those 2 points in common of 0, 0, 1, 1. We can see the graph of a linear function is a straight line, and the graph of a quadratic function is that U-shape called a parabola. Okay, so let's review those transformation rules that we've learned. So first, how do I transform a quadratic function left and right using translations? Well, to go left and right, we use the opposite and we put it in with the x. So we substitute in for x, x minus h. To shift up and down, we add to the end of the function. So we add k at the end to go up, we subtract k at the end to go down. All right, so let's just practice looking at those two types of transformations. So it says, using the graph as a guide, describe the transformations and graph each function. So our first one is g of x equals x plus 3 quantity squared plus 1. So we're going to identify our h and k. So first we can see here that h is actually negative 3, because remember it's always the opposite of what you see. And then our k is plus 1. So that means that our function moved left 3 and up 1. We can graph this using Desmos. So one option we have is we can put this function, g of x, into Desmos or our graphing calculator, and then we can look, did it actually move left 3, up 1? Or if you're feeling very confident in what you are writing, like I do, we can just go ahead and graph it using those 2 points. So we know that it usually starts at 0, 0, but we went left 3, up 1, so I can draw just a simple sketch right here of my new parabola. Let's look at our second example. We have g of x equals x minus 2 squared minus 1. So first identify your h and your k. So remember, h is always the opposite. I see a negative 2, the opposite is a positive 2. And then k, okay, is you see what you get. I see a negative 1, it's negative 1, it's down 1. So opposite of negative 2 is positive 2, so this is a right 2, and then a down 1. Again, you can choose to graph this using some kind of graphing device, or you can do it by hand. I know that this went right 2, down 1. The parabola's vertex is what that's called, is right here. Okay, let's review our other types of transformations. We have reflections, stretches, and compressions. So we'll highlight some key points here. First of all, a reflection across the y-axis. That's when it would flip across the y-axis. That's a horizontal change, so it gets substituted in for x. It happens inside. A reflection across the x-axis would flip it up and down. That means it is a vertical reflection and the output changes. We make the entire function negative. Horizontal stretches and compressions, remember that happens inside. It gets substituted in with x. And remember that word that we have to use when we see a horizontal stretch or compression. Say it. Yes, reciprocal. And then finally, we have our vertical stretch and compressions. Again, those happen to the output. It is a multiplier for our entire function. Okay, so let's try a couple more of these. So we're going to use our parent function as our guide. We're going to describe the transformation and then graph each one. All right, our first thing, remember our parent function is just this x squared. So I see two things, okay? I see a negative sign in the front, and I see a 1/4 in the front. Well, remember a negative that's outside of the function is a vertical reflection, or what you could also say, okay, remember vertical reflection means it's reflecting up and down. You could say it's a reflection over the x-axis. Either answer is acceptable. You can say vertical reflection or reflect over x. Both are 100% A+. Actually, I don't give A+, it's 100% A. All right, now we have the 1/4 out in front multiplying. A multiplier in front of the function is a vertical stretch or compression. When the number is less than 1, it is a compression. It's going to compress it vertically. Vertical compression of 1/4. And I'm going to let you go ahead and graph that on your own. Next one. Remember, x squared is our parent function. The only other thing I see is right there, that 3x, that 3 being multiplied inside with the x. Remember, when there's a multiplier inside, it's a horizontal stretch or compression. But before we can use any vocabulary, the first thing we have to do is take the reciprocal. The reciprocal of 3 is 1/3. So when we're using the number 1/3, we have to use the word compression because 1/3 is less than 1. So this is a horizontal compression of 1/3. Okay, I'm going to go ahead and pause the video here, and then we're going to talk about vertex form and a few more transformations with that.